that if we can also add two vectors. If I am adding two vectors and if it is giving me addition of two vectors will produce some kind of a different vector which will also be a vector. Okay, because of this simple nature that a vector which is having direction, so it will also add with the same direction and it will give you the another vector which is which will have the consist of this complete complete vectors. Now in vector there is a very famous rule called triangle law. Okay, a very intuitive idea that it's triangle law true for vectors. If you have this a vector from going from here to here and you take another vector which is going from this arrow and it has some tail over it, therefore b vector, then the resultant vector, one can go from this side to this side or simply this way, c vector. So this is the triangle law which has been stated here, that you have to follow which path is continuous one. So this is the continuous one, so a and b goes from here, so we are going from this way to this way, and then the c vector is here called the resultant vector. Okay, so this is the triangle law. If any vector follows this rule, then one can say that yeah, this is the vector. So this quantity possesses this this law, and one can state that yeah, this is has to be vector. Okay, well, so far any questions? If you have questions, please write it down in comment box and you can ask, you can email me to ask this thing. Now following the triangle rule, for an example, let's take an example. Suppose you have this vector a here and this vector b here. Now I say that whenever you construct this triangle law, which is very important to solving problems, so you see that we have to follow this cycle here. But you know, see, if I am taking this origin here, so it's coming from this way, this side to this side, so there is nothing to follow here. So the thing is that whenever you try to construct this coordinate system, and if you see that I have to go from this point to this point, so you see that I am making a resultant vector that is called c from a to b, or maybe b to a I can construct. So it depends on in which direction you want to go, and again we follow this path, that where is the continuity. The continuity is here. If I am going a to c, then it will become 0 to b. So how it is that? A vector plus c vector, so I can always get from this 0 to b. Therefore my c vector would be b vector minus a vector. So this is how we can formulate this triangle law, which is very pretty intuitive and amazing. Let's dig deeper. Let's dig a little bit deeper in this additional thing, because we are adding two vectors and it will give another vector, another resultant vector. Now what else? If I am changing the order here, suppose b vector plus a vector, so the order was a vector was adding towards b. Now I am changing the order, that suppose b vector is added towards a, so the change in order will remain the same. Okay, so it happens with addition, because we are adding this two vector. The reversing, changing the order won't affect the outcome. So this change of vector which doesn't depend on outcome or the order, we can change, we can switch the orders, we can call it commutative law. Commutative law of addition. Similarly, we can have this distributive law which says that if I am having three vectors, b vector plus c vector, if I am adding first this guy and then adding to this one, will be similar to a vector plus b vector. First do this operation here and then add the c vector. Well, you may say that why you are teaching this stuff, that addition, commutative law and distributive law, or maybe some different things, because you don't understand the power of these kind of things. When you will study the groups and theory, or you will study the particle physics in greater detail. So there are so many, or in quantum mechanics, not in classical mechanics, but in quantum mechanics, you will see that these rules are the fundamental rules to construct any concept, go beyond something. That's why these concepts, associative law, commutative law, is very much important. Okay, now one can easily multiply any vector by some scalars, means that 5 multiplied by a vector or 6 multiplied by a vector. If you are multiplying some negative quantities, like for example 10, so it will reverse the direction of this a vector. What did I mean? The meaning is, the meaning of multiplication is that you have vector, which I have already told you is nothing but an arrow. The size of arrow gives you the magnitude, and the way, where is the direction, it depends on this head. Okay, so it's this side, and if I'm making multiply by the 5, so it will become this guy here. Okay, it is 5 times this one. Now if I am multiplying this same guy with -5, so what will happen? The head will go this side. If I am having these two vectors this side and both have same direction, then it will add it towards this one. But if having this vector and this vector, and if I want to add it, they cannot be added. So this will remain as it is. So if this is my x hat and this is y hat, so this will become nothing but x hat and y hat. You cannot add the magnitude of these two vectors. Similarly, we can have this vector, this one, and we want to add another vector, maybe some smaller. So what will happen? So this will get subtracted because it has different direction. So this vector will be shorter. But since this vector is smaller than this one, so it will reduce the size of the vector, but it will remain on this direction. Okay. Now if I am taking the same size but in reverse order, so we will get this 0 vector, and 0 is also a vector. So it is just like some point, or may not be, it's not nothing, but it's simply this point or something. So we can say that it's a 0 vector. So if I am having a vector and added with minus of a vector, it will give you this 0. 0 is magnitude also, and 0 you can treat as a vector also. So this is the whole thing about addition and multiplication by some scalars, and how one can add the vectors. So this is the very simplified rule to understand vector. Now let's move to some different thing called product. Can we do some product with vectors? Now it's a very fascinating thing. Fascinating why? Because the product can be done in two ways. One is called dot product, star product, and another is called vector product, or let's say one can also say that it's cross product. I hope you can understand my handwriting. The dot product is represented by, for example, you have two vectors, a vector and b vector. So we are dotting it. Now while we are dotting it, we will always get some scalar quantity. That's why it also said that this is a scalar one. A scalar only would have only magnitude. So I got this one vector, I got this two vector, and the resultant will be some scalar always. Okay. One can also break these two things. For example, these two vectors having some angle, a vector and b vector have some angle here. So one can say also that AB cos theta. The angle will be simply, you can write also here. So if I am writing this way, it is called magnitude, which is same as A only. Okay. So whenever I write this kind of, instead of this, I can write also this one. These both are same thing. So you can break also AB cos of theta, whatever the angle between it. This is the way of representation it and way of writing it. And another way of writing is, suppose you are having a vector, maybe ax x hat plus ay y hat, and let's say b vector is bx x hat plus by y hat. Now I am saying that okay fine, do this operation. What will you get? This C vector. Now you can say that's x hat. So particularly we have this A vector and B vector, and if I am telling you to find out A dot B, so you may say that okay fine, we can do this A vector and the magnitude of A B cos theta. But you see, I haven't given you the angle of it, and we can also ask that what could be the angle of angle between these two vectors. But more importantly, but can we have this different method that we don't have some angle and we can find out what is the product of it? Well, yeah, we can have. So what else can we do? That ax x hat, ay y hat dot by y hat. Okay, now here we can say this is a simple thing. Ax and bx is the magnitude, ay these are magnitude, so we can write it here ax bx the same way you do this product in your high school. Ax by, so this is nothing but ax by. I am having this ax x dot y dot. Now see, you have to remember this ordering, that how you are multiplying over it. Now again ay bx, this is will be y dot x hat, and then again ay by, so y hat dot y hat. Now we can say that okay fine, we know what is ax bx, it may be some magnitude 1 1 2 2 3 3 something, but I don't understand what would be this x hat and x hat. Well, x hat, suppose x hat is the vector which is represented by this one, so another x hat is also this one. Now actually we are saying that whatever we are doing, it will give you this magnitude. Okay, so x hat and x hat, the angle between these two guys are 0. I know the angle here, so we will use x hat dot x hat to find out that this is the magnitude of this thing, and cos of theta. I know this, the magnitude of x hat is 1 and this is 1, and cos 0 is 1, because we know particularly that these two vectors are same, that's why the angle between it is 0 1. So 1 1 1 will always 1. So therefore we can say that x dot x dot will give you always 1. So this is the 1, and similarly goes for y hat dot y hat, it's 1. But what about this x dot y dot? Now same thing, this is x hat, this is y hat. The angle between these two vectors are 90 degree. So x dot y hat gives you this x hat y hat, this is 1, which is 1, but cos 90 will give you 0. So 0 multiplied by anything is 0. Therefore any vector which is mutual to another vector will produce, two vectors are orthogonal, so they will always produce this 0. So this guy will be 0, this guy will be 0, or maybe anything. Maybe you say, let's take z. So x dot z hat, it will also give you 0. Therefore, I don't have any space here. So yeah, this I can write this side ax bx plus ay by. This is the resultant of this A dot B. Now if you have this result, this is the number, some number. Now you can find out the C. I have already told you how to find the magnitude of this guy. The magnitude will be simply ax square plus ay square, then simple this one, and again cos theta. So cos theta will be this whole guy over these things, and we will get what will be the angle. But if I am telling you that what is the A dot B dot, so we can do this kind of thing. If you have this component, and you will figure out what is your C. So this is the resultant way to do this thing, scalar product. So the important thing that we have noted here in scalar product, that will be deeper, x hat dot x hat, any two vectors in same direction will produce 1. Any two vectors are orthogonal to each other will produce 0. And again we see that any two dot products of any two vector will produce another scalar, and this also equivalent to A magnitude, B magnitude, and cos theta. And we also saw that if A dot B is produce you 0, then the angle between these two things is 90 degree, means that these two vectors are orthogonal to each other. So if anybody will ask you that prove is two vectors are orthogonal to each other or not, just do this dot product and you see does it give you 0. And if it is producing 0, then one can say that yeah, these two vectors are orthogonal to each other. So this is the whole thing about dot product. Let's move towards a very interesting thing called, before we move in, one part is, if I doing this dot product like this or this b dot a, the resultant will be same because we are talking about this scalar. Scalar will be same. So we can change the order, but everything remains as it is. Answer won't affect. This is called commutative. Okay, commutative law. So a dot product is always commutative in nature. You can change the order of two vectors and the product and the resultant will remain the same as it is. So this is the very beautiful thing about dot product, that it is commutative.